There are thousands of molecules exist in the nature. Some of them are ionic, some are non-ionic. But how do they form from elements? That is our topic today, chemical bonding. It is a kind of attraction between the atoms of same or different elements. First of all, we shall try to find out what is the reason behind chemical bonding. For that purpose, we have to know the electronic configuration of inert or noble gases, as they are the most stable elements in our nature, and all other elements try to get that configuration. There are 6 inert gases present in our nature: helium, neon, argon, krypton, xenon and radon. Except helium, all of them have 8 electrons in their outermost shell. Helium has 2 electrons in its outermost shell. Now, the elements having atomic number close to helium will try to get the outer electronic configuration of helium, commonly known as duplet or doublet completion. As for example, lithium, atomic number 3, electronic configuration is 2, 1. It will release its outermost electron to get the structure of helium. Again, hydrogen, atomic number 1, will take 1 electron to its outermost shell for the same reason. Similarly, for sodium, atomic number 11, electronic configuration is 2, 8, 1. It will release its outermost electron to get the structure of neon. Again, chlorine, atomic number 17, electronic configuration is 2, 8, 7. It will take 1 electron to get the structure of argon. As there are 8 electrons in their outermost shells, in both cases it is commonly known as completion of octet. Chemical bond formation can be carried out in 3 possible ways. Thus, it can be divided into 3 categories: electrovalency or ionic valency, covalency and coordinate valency. Before going in details of chemical bonding, we have to know the nature of elements belonging atomic number 1 to 20. This is a portion of periodic table where metals, nonmetals and inert gases are segregated. The nature of a metal is to release its outermost 1 or more electrons to form a cation, and in reverse, the nature of a nonmetal is to take 1 or more electrons to form anion. Now, if a metal and a nonmetal come close to each other, then an electron transfer will occur from the outermost shell of that metal to that nonmetal, thus producing 2 opposite charged species, commonly known as cation and anion respectively. They attract each other by Coulombic force and form an ionic compound. These are some examples here. Thus, the chemical bond formed between 2 atoms by transfer of 1 or more electrons from the atom of a metallic element to an atom of a non-metallic element is known as ionic or electrovalent bond, and the compound thus produced in this process known as ionic compound. As metals are involved here, so the ionic compounds are solid. Melting and boiling points are high. They are soluble in polar solvent like water and very good electrolyte. But one thing to remember, ionic bond is not a true bond. It is rather an attraction between 2 opposite charges. They exist in ionic form in solid crystal also. That is why we should use the term formula weight instead of molecular weight for this sort of compounds. Now come to covalent bonding. When two nonmetals come close together to produce a molecule, this type of bonding has taken place. Here the process of bond formation is completely different. Both of the atoms of same or different element want to get electron as their non-metal. Let us see for hydrogen molecule. Here both of hydrogen atoms need one electron to get helium gas configuration. They do so by formation of an electron pair first and followed by sharing it equally. As there is one electron pair, we write it as single dash, that is single bond. However, for oxygen molecule, both of oxygen atom need two electrons to get the inert gas configuration. So they do so by sharing two electron pairs, which is known as double bond. Similarly, for N2 molecule, an N triple bond is formed. Thus, covalent bond formation has been carried out either by single or double or triple bond formation depending on their outermost electronic configuration. Now let us see for a complex molecule like HCl. Here both hydrogen and chlorine atoms need one electron each for their stability, and they do so by formation of one electron pair which ultimately share by themselves. Similarly, for water molecule, here oxygen atom needs two electrons and two hydrogen atoms need one each. They ultimately satisfy themselves by formation of two OH bonds. The electrons which are not involved in the bond formation are known as lone pair or non-bonding electrons. For simple covalent molecule like H2, O2, etc., the electron pair involved in bond formation stay almost middle of both atoms as they attract that pair of electron equally. These are called non-polar molecule. However, for compounds such as HCl, H2O, etc., chlorine and oxygen atoms draw the bonded electron pair towards itself due to greater electronegativity of chlorine and oxygen atoms than hydrogen atom. That is why they are polar. Now the property of covalent compounds. They may be solid, liquid or gas. Their boiling and melting points are generally low. They are non-electrolyte and they are insoluble in aqueous solution but soluble in organic solvent. However, there are some covalent compounds which are soluble in water. Thus, the chemical bond formed due to mutual sharing of electrons between the given pair of atoms of non-metallic elements is known as covalent bond, and the bond formed by a shared pair of electrons, each bonding atom contributing one or more electron depending on their electronic configuration to their pair. Coordinate bonding, also known as dative bonding. It is another type of bonding like covalent bonding. However, it involves one of the atoms contributing both of the shared electrons. That means a bond formed by a shared pair of electrons with both electrons coming from the same atom. An arrow is drawn here instead of solid bond, indicating electron shiftment from donor to acceptor. As for example, a coordinate bond is formed between oxygen atom of water molecule and H plus ion to produce hydroxonium or hydronium ion. The H plus gets the helium gas configuration in this way. Here, the donor is oxygen due to presence of lone pair and acceptor is H plus, however shared by both. Similarly, ammonia and H plus ion form a coordinate bond to produce ammonium ion. Property of the compounds having coordinate bond are very much close to the covalent compounds. They may be solid, liquid or gas. Their boiling and melting points are greater than covalent compounds but lesser than ionic compounds. They are generally soluble in non-polar solvent and solubility is very poor in polar solvent. They are generally bad conductor. This is all about chemical bonding in a nutshell for class 10 level. Now go through your book and complete the exercise in it.